Hi, my name is Marc James, and I'm the Area Vice President of Sales for MiTek. I've been to a lot of plants, and I get asked a lot about best practices for truss manufacturing. It's definitely a place that a lot of plants could improve on, and a big place to bring some money down to the bottom line to eliminate some labor and to eliminate wasted movements. So I'd like to take a moment and talk a little bit about what each individual operator should be doing in an optimal way to build a truss. Then I'm going to have a video example that we'll walk through so you can see how these concepts in theory work in the real world. I'm going to be talking in terms of a single build station on a standard gantry with 3 operators. In this case, I'll be referring to them as operator A, B, and C. You're going to find that each one of these operators has a very specific task, doesn't have to work very hard within those individual tasks, and shouldn't be moving around that much. You might be surprised. Let's take a look. So when you're getting ready to build a truss, as I mentioned, 3 operators. Operator A is only working on the left side of the truss. Operator A is also typically the lead builder or the lead operator. And they're also the one that is going back to the operator station and utilizing the paperwork or hopefully the MiTek virtual plant software to get different truss or batch data. Operator B actually stays up on the table. They are the peak operator. Often, this particular operator is the new person or maybe someone that's more green. And the reason is because material and lumber is handed to them on the table. They don't have to make many decisions when building the truss, and you'll see why that's important. And then operator C, of course, is on the right side of the truss. I would call them like the support operator. They're the one that is, again, working the right side of the truss. They're also the one that is gathering connector plates, and they are the ones that are sort of just ensuring that lumber carts and material is properly staged and ready to go for the next truss. All right, so let's look at step 1 in the build process, which is operator A and operator C physically sets the top cords onto the gantry. In this example, there's just 2 top cords, but it might be a 2-piece top cord resulting in 2 or more pieces. They would just go ahead and set all of those pieces up on the table. While they are doing that, operator B grabs his nail gun and pops a few nails into the peak of the truss just to make sure everything stays nice and sturdy during the process. Next, operator B is going to continue stapling parts of the top cord, especially if it's a 2-piece. He's also going to walk down and prepare to staple some of the heels on the truss. At the same time, operator A and C are laying the left and the right bottom cord in place. Same thing, there may be a 2, 3, or even 4-piece bottom cord. All of those are laid in place at the same time. While that's happening, operator C is going to put a few staples in those bottom cords. Again, we just want to make sure that the perimeter of the truss stays nice, locked, tight, and in the jig. Next, this is where things start to change a little bit, where operator A is going to grab all of the webs that are needed for this truss, and he's going to lay them out. Sometimes on larger trusses, they're laid out from left to right. Other times on small trusses, he sort of sets them all down in the center and then fans them out. Either way is fine, depending on the size of the truss. At the same time, while he's doing that, operator C is going to gather the connector plates needed for this particular truss. Not job, just the truss. Hopefully, he can go back to the plate rack and either refer to whatever paperwork he might be using, Or even better, he can refer to an MVP screen that's going to show that operator exactly which connector plate he needs. Or best, he can just take a look at the LCD or LED or even projection screen that should be hanging over the table and get a better view of which individual connector plate is needed. And once he grabs those, he'll just sort of set them near the joints in which they need to be adhered to the truss on. The next step is the group works together to physically set the connector plates in place. They're going to tack them with one hit of the hammer. They're going to tack them on one side or the other of the connector plate. Usually it's on the leading edge in which the gantry is going to roll the truss. At the same time, they're going to use a claw hammer to lift that joint up and slide the bottom plate in place underneath the truss. Operator A is going to primarily focus on the joints he can reach on the bottom left of the truss. Operator C is going to focus on the plates he can reach on the bottom right side of the truss. And then operator B is going to focus on all the plates on the top cord and the top cord webs. Going to the final step, this is where things, again, alter just a little bit. Operator B, who's working the peak, if they are working on a side eject system, that operator is going to jump onto the gantry itself and drive the head across the truss, pressing the plates. Operator A is going to go back to the MVP station and advance the auto jigging or the jigging to the next truss and ensure that the display screens are updated accordingly. If this happens to be a end eject system, it's going to be that operator A that drives the gantry head back and forth. And finally, operator C, while those other tasks are happening, is going to glance over and make sure the correct cart is in place and the correct lumber is teed up on that cart for the next truss to be built. So that's a lot of information, and I would like to walk through a video that shows this exact process. What we're about to look at is a 23-foot truss built on an end eject system, and these operators work very, very well together. There's very, very minimal wasted movement during this manufacturing process. So let's take a look. As you can see, that truss is rolling out of the building through the finish roller. And operator A has already started to put the top cord down on the gantry. Simultaneously, operator C has set down the top cord on the right side of the truss, and the bottom cords go up. You'll also notice that operator B, working the peak of the truss, is walking around stapling the perimeter to make sure we have a nice tight joint at each location. And while that all happened, operator A has already set the webs to the truss out and fanned them out. Everyone has their hammer out now. They're going through each individual joint. First, they set the top plate. Then they use the claw of their hammer to slide the bottom plate underneath in a precise manner, working the entire truss. Operator A stays on the left, operator B stays on the peak, and operator C stays on the right. You'll notice as things are finishing up, operator A, or the lead operator, walked over to drive the head over the truss, set all the plates. This particular plant created a little platform for the peak operator to safely step off the top of the gantry without having to walk down steps or jump off the table. So much more ergonomic. And once that's happened, the truss is ejected out of the building, and the operators repeat the process by throwing that top cord right back up and moving forward. So this process is very, very simple and very, very repeatable. This particular case, they built that truss in 1 minute and 39 seconds, which I think is a fantastic number for a 23-foot truss. I'd love to take just a moment and do a quick review of the individual operators in their individual tasks. So we'll take a look at operator A. Remember, operator A stays on the left side of the truss. They are typically the team leader, and their primary focus is ensuring that the next truss is teed up in MVP, or the next batch or the next job is loaded. They're focused primarily, again, on the left side of the truss, and their primarily focus is getting that top and bottom cord on the table as quickly as possible so the peak operator can begin stapling off the perimeter. They're also going to be focused on getting the webs in the truss, and they're also going to be focused on setting the connector plates and making sure they're placed appropriately on the bottom left-hand side of the gantry. As a special note, this operator does indeed drive the gantry head when it's in an end eject situation. Operator B is the peak operator. They never get off the table. Again, we're looking to minimize anyone getting hurt and maximizing our ergonomics. Their fabrication steps are a little bit different, as they are in charge of stapling the perimeter of the truss after the pieces are put into the jig. They're in charge of making sure the webs are placed correctly and stapled into place if necessary. And they're in charge of setting the connector plates on the top side of the truss. If they are building on a side eject system, it's operator B that steps onto the top cord riding platform and drives the head back and forth. And finally, operator C has another set of tasks. They are typically gathering the connector plates, typically sorting lumber and making sure carts are in the right spot, and ensuring kind of everything's in place so the job flows smoothly. Their focus is the right side of the truss, placing the top cord first, the bottom cord second, making sure that right heel joint is stapled, making sure plates are picked and placed in the correct area, and then, of course, making sure all the plates are set in the proper location on the bottom right side of the truss. So very simple. It only takes 3 people to do this. And if these steps are followed and a computer is placed in the correct area driving the MiTek virtual plant software, if your carts are placed in the right spot and the lumber is stacked in an appropriate way and connector plates are easily accessible, your plant too can achieve these numbers without having the operators move and run around and have chaos at the table. It can be a very, very smooth process moving forward. Thanks for joining me today.